while to continue on the fun. And with that, I will hand you over to Antonello, who is the lead data engineer here at Wise. So,
hi, guys.
To discuss Archival.
I'll close this one second. Okay, hi, everyone. My name is Antonello, and I work as a lead data engineer in the finance team. Welcome, everyone. Why are we here today? So, there are three main reasons why I wanted to give this speech. First of all, to tell you a story, to have fun, but also because we are hiring. So, and I think it's a way to a little bit cut corners and have a lot of smart people in the same room at the same time. So just checking, how many of you are already working in data engineering? If you can raise your hands. Okay, I will say 20%. How many of you are? How many of you are currently studying, computer science or, any other form of, study at university? No one. Oh, there are a few people actually. Good. How many of you work in other fields? Last question, like analytics, yeah, and the rest of the industry. Cool, cool. So today with us, we have the privilege of having the finance head of data and analytics, like the back, that is my boss, Brandon. So if you are looking for a job, Brandon, do we have a new open role? Like, yeah, do we have budget? We have budget for a new role. And also we have Moritz. Where is Moritz? Yeah, Moritz is analytics lead 3. There's only the Pope after Moritz. So if you guys are, looking for a job, please, these are the guys you need to contact. Okay, a little bit about myself. You know my name. So if you want to, let's say, connect with me, that Unbento4 is my LinkedIn profile. Please do. I've been at Wise for 3+ years now, 7 years of experience in fintech. I started from a company called, I started from Deliveroo, actually. Then went to Ria, then to a competitor, Wise, World Remit. And then from 2022, I work in the finance team. I started as a senior data engineer. On the side, I work on projects. I try to write something on Medium. I like sport, and I started recently playing guitar very, very badly, though. So, okay. So the title of this speech is how I created a data archival service with PySpark and Iceberg. And there's been a lot of interest in Iceberg recently. And so we would like to share with you how we managed to build it and why we found Iceberg being like a good solution. So data archival service, what is it and why is it needed, first of all? So the service is a service built as a PySpark application owned by the data engineering team in finance. And in finance, we have something we call critical data sets. And we also perform cold storage of legacy data sets. So we needed something to perform backup on a monthly basis. And why did we need something like that? Well, the first reason is that we are using Snowflake to do enrichment mainly. And there's a little detail that, we use, like Snowflake, but Snowflake is not a tier 1 service currently at Wise. So we needed a fast solution to actually back up data on a monthly basis. And also, the data size of our datasets was becoming too big. So we had a previous, let's say, backup tool, but it was not working that well at scale. We were actually backing up datasets in CSV format and also in Parquet format. and we were hitting really a limit. So we needed some more power, and we needed fast. So we had to get very creative very soon. And to understand why we had to get creative soon, I wanted to share with you our platform engineering, like our platform, data platform works currently at Wise. And it's pretty interesting to see how all these teams collaborate together and what they are helping us to solve, and what are the current bottlenecks. So you can see that currently we have the platform team is split in 4 segments. We have analytics platform team that is mainly managing Snowflake database, let's say pipeline-wise, that is what we use to replicate data in between databases. Then Kafka, Flink, and of course, the next generation tool that we are going to use to, of course, replicate data. Then we have analytics experience that is managing the dbt infrastructure and also the visualization tools like Looker and Superset. And then machine learning platform team, they are currently owning Airflow, EMR, and let's say SageMaker, but much more than that. So this is a simplification of what these teams are currently managing. And then we have Cloud Foundations that is basically responsible of managing the lakehouses and all the ecosystem around the cloud. And then basically these teams are supporting us. And within the finance team, we have software engineering segment, data engineering segment, and then we have a number of sub-analytics teams. So you see, like, there needs to be a lot of interaction between us and the platform team. But of course, they prioritize certain topics, and we are not always able to push what we want on their agenda, so we need to get creative. And this is good because Wise allows you to build your own tool and gives you the freedom to be creative indeed. Okay, how are different technologies used in this data archival service? Let's see. So first of all, we are using Airflow as a scheduler to trigger the submission of of a PySpark application to EMR. And Airflow in this case is used as a pure scheduler. I know that sometimes in this industry, people tend to use Airflow as a way to also compute. And they are using the memory on the worker to do the computation, but actually Airflow should be used in using like an orchestration versus computation paradigm. So it should be only used to submit jobs. Then we have EMR, that is basically where the computation is happening. So once the job gets submitted by Airflow, it gets actually what needs to be computed is actually computed on EMR. So the application is running actually on EMR. PySpark is the programming language used to build the application itself, and Iceberg is the format used to store data so to perform backup and cold storage. So these are the main technologies, and let's see how they come together. But first of all, let's understand why Iceberg format is becoming so popular. So many of you on LinkedIn and that are reading stuff online might be familiar already with Iceberg. Perhaps you work on it like on a professional environment. Perhaps you're looking to do so, or you're looking to learn more. Why is Iceberg becoming so popular? First of all, it's built to work well with large data sets. So is a building block for data lakehouses. It works well with batch processes, and it works well also with streams. One of the best characteristics of Iceberg is acidity. So basically all the tables that you store in Iceberg format de facto behave as a table stored natively in a data warehouse. So atomicity, consistency, isolation, durability, they are all, let's say, concepts applicable to data manipulation language in SQL. So they behave exactly as tables. Another very nice characteristic is like the schema evolution. So you can create a new field without having to rewrite the entire file each time. And then there is this concept of, let's say, time travel, snapshot isolation, meaning that you could go back in time and see a previous version of that table. You could do some testing, run some data, you run some machine learning models, do a little bit of exploration, and then if you see that something doesn't look right, you go back and apply the previous version of the table, and you go back to the original state. And another very important thing, last but not least, is that it's compatible with a lot of different engines. So very versatile, Spark, Flink, Kafka, Hive, and I forgot to mention Trino. We will see why Trino is important later on. And you can write in Parquet, OCR, or Avro format. And an interesting note, if you didn't know, is that also Snowflake apparently behind the scenes is storing data in Iceberg format, version 2. And I'll tell you a little bit more about difference between version 1 and version 2 in a second. And a lot of other companies are investing quite a lot in this technology, including Wise. And one question might be, why do we need to keep using Snowflake if Iceberg is that good? And if someone has the answer later on, we can discuss about that. Otherwise, I'll give you my opinion. And that's it in terms of, I mean, there are many other features. Like there's another feature that we discovered recently with my team that is branches. So you also have, you can treat Iceberg as it was, an Iceberg table as it was like a GitHub repository. So you can actually create branches, name branches. They work more or less like snapshots, but they are much more user-friendly because you can assign a name. So you can assign the name of a project or a feature you are working on, and then they expire after a while. So it's quite cool. There's quite a lot happening behind the scenes. So components. So next slide looks good on my, but when I show it here, it looks very blurred. Okay, let's go by step. Sorry for that. So the main components are, first of all, configuration. When you are creating an application, configuration is paramount. What we are doing here is basically we have a table configuration in YAML where we are specifying the tables that needs to be backed up or sent to cold storage. It's very easy. On the slides, we will circulate the slides. You will be able to see what I mean, and it will appear much clearer than it is now. We did it in YAML because it's very approachable by analysts as well. So it's very intuitive. It's like writing in plain English. You can do pretty much whatever you want with YAML configuration. It behaves like JSON behind the scenes or something like that. Then you have Spark application configuration. Of course, this is just a screenshot. It's not the entire configuration. It's much longer. It's what we use to actually tell to EMR what needs to do with that application, which files needs to be imported, which is the main application, which are the jars that needs to be imported to run the entire application. Then we have a data archival service class that is pretty much the backbone of the service itself. And the main application that is usually very compact. So in the main application, we are just importing, let's say, the main class and then methods in that class. So when we actually make changes, we make changes to the data archival service class. We almost don't touch the main application, or we change configuration. This way, the advantage of this is basically that the moment you want to switch to Java, or you want to stop using, let's say, Airflow, you want to start like using Kubernetes as a scheduler, you can do it. You can pretty much, this application is very transferable. It's built in a modular way. So it doesn't matter which scheduler you are using. If we had to decide, and in general, within WISE, it is starting to rise this need of like moving away from Airflow for some applications. While historically we have been doing quite a lot with Airflow, running services with a scheduler is not the best. A service should have, like its own scheduler, and Kubernetes is a potential alternative. So we are trying to build stuff now in a way that it is transferable easily if we had to migrate to Kubernetes permanently. And that is something to note. And again, sorry if it is blurred. It will be much nicer once you look at the slides, the original ones. Oops. Sorry. So how does it work in practice? Okay, so step one. So everything starts in our repository, Airflow Finance on the left, where we store actually all the components, the configuration, as well as the main application, and of course, the main class. So what we do is one task is uploading all these, let's say, all this configuration and all these assets to a dedicated S3 bucket. And this is needed because in EMR, EMR needs basically a place where to find this information to actually input these assets in the main application. So the easiest way is actually to configure EMR to have access to a specific S3 bucket. And then in this S3 bucket, you usually have a configuration folder. Then you have, in our case, we created like the main Iceberg warehouse. And the other thing we usually put in this S3 bucket, actually in reality, we have another S3 bucket where we are keeping all the jars. But to simplify, let's say that also jars are included in the main bucket. And so once we have all the assets in the bucket, we do something else. We generate the step. And the step is basically a command that is saying, is a string that gets generated with all the instructions for EMR to actually deploy the application. So once a step has been generated, this is how it looks like in the in DMR UI. So you see that what generally happens is a step ID gets assigned. You have the name of your application, and then the application, hopefully, if the if the cluster is running fine, completes. And you see that this specifically took 49 minutes. We were probably doing some monthly jobs. And the important thing about EMR is that it can be scaled up and down. So if your company grows and your needs grow, or you really need to run that 10 terabytes job, you can scale it up temporarily with Terraform. For example, you can deploy a different machine that is much bigger, can do the job, scale it back. You just pay for what you need. And that's why, having an external, let's say, cluster that is doing the computation is very handy. So as much as we can, now we will try to move from standard DAGs, so from standard pipelines to PySpark pipelines as we see fit. Then what happens? So we have this step deployed. The step is running in EMR. So actually the application gets executed. And in EMR, we need something to check that the application is healthy. So we built like, that there's actually a, in Airflow, you can create a sensor that is poking the application every, 10, 15 seconds to check that the application is healthy. Of course, all the assets are read from the S3 bucket that we created before. So the application ideally has everything it is needed to be executed in full. Okay, and the output of this is basically that we first, as part of the application in the archival service, what do? We query Snowflake native tables. These Snowflake native tables are parsed, and we insert the delta, so what is missing from Iceberg. So we incrementally, let's say, append on the tables in the Iceberg warehouse. And what we can do, like as part of this application, we can decide whether either to actually store in Iceberg format or to store in Parquet format. And sometimes, storing data in Parquet format is useful because currently Snowflake supports something called external tables. I don't know if you guys ever heard about external tables. And external tables are quite useful because you can store a data set in a S3 bucket in a lakehouse in Parquet format and build a table in Snowflake on top of it. And analysts can actually query from that table with SQL. So now if you build a pipeline that is writing to S3, the output of this pipeline can be pretty much queried out of the box by analysts by building external tables. External tables have some caveats that we will discuss shortly. So we can decide as part of this service whether to go to Iceberg or to go with Parquet. So some notable features, as we were saying, we decided to go with YAML configuration. We believe, that it's not difficult to understand how YAML is is much more readable than JSON. Is very approachable by analysts. We have analysts that are actually, working with YAML files themselves. So we found it being like a good solution. As part of this archival service, we can decide to go with two strategies. We can archive data using a deleted insert strategy or a merge strategy on Iceberg tables, of course. This service is completely automated in a sense that it is able to check whether a table already exists. If it doesn't exist, it's able to retrieve the information it needs from the information schema in Snowflake, meaning all the data types, in a sense that you're not going to have a data type mismatch in your Iceberg table versus your Snowflake native table, so your source table. And also, as we were saying before, you can decide to store data either in Iceberg or Parquet datasets. And also, EMR can be scaled up over time to meet the needs of your team. So we were saying that actually we can actually build external tables on top of Parquet. So that should solve the problem, right? Why do we need Iceberg? So the first problem with Parquet is that there's no atomicity, and the other problem with external tables is that you constantly need to refresh them. So as new information gets appended in S3, so to the Parquet dataset, you need to constantly run a job that is refreshing the information in the bucket. So we can query information from Parquet dataset using Snowflake and external table, but how do we query information from Iceberg then? Okay, so in order to query information from Iceberg warehouses, we need to introduce a concept, the AWS, the catalog concept. So in order to, Iceberg tables are actually part data, part metadata, and both metadata and data are actually stored in the S3 bucket, so in the lakehouse. But we need a way to understand what's the most recent version of this data. So we need a way to create a pointer to the right, let's say, to the right metadata file. And this is what catalogs are useful for. So catalogs store pointers to metadata to allow us to understand where we are which version of the table we are using. So catalogs are also important for manage access and security. So let's see what's the current state and what the ideal state will be. So let's meet Frankie and Chris. So Frankie is my spinning instructor, lovely lady from New Zealand. And Chris, so let's say that Frankie is a data engineer in this case, and Chris is my guitar teacher, very talented one, and he's an analyst. So a data engineer currently only needs to pretty much, the data engineer built the PySpark application. So with the PySpark application, we are actually connecting to Iceberg tables via EMR. So we are using a service user, meaning that the data engineer is already happy. The data engineer can use PySpark SQL API to query directly from Iceberg tables. Whereas the analyst is not that happy. Chris is not happy at the moment because Chris needs to actually query from Iceberg using Trino, authenticating via SailPoint. But currently in the data engineering team, we are using Hadoop as a catalog. So we decided to go with Hadoop. And Hadoop is not it's not a catalog centrally supported by the company. The only catalog centrally supported by the company is the AWS catalog. So in a ideal state, we will need to migrate our Iceberg tables in finance to actually from Hadoop to the AWS catalog. In this way, also Chris will be able to connect via Trino to Iceberg tables and run SQL on top of that. So the problem we have now is that like what we had to build in order to be fast and to go to production, we had to choose the simple option, that is the Hadoop catalog, whereas in the future, we will need to migrate to something that is supported centrally. So currently, we have Frankie, the data engineer, that is happy, but Chris is not so happy. And we need to, in order for data engineering to be happy, also analysts needs to be happy. So we will need to find a solution. And what will be the future state, even better state? The even better state will be actually creating, having a federated catalog. So having a solution where we don't need actually to perform a migration from Hadoop to Glue, but actually recently we went to the Chill Data Summit and we were discussing about Iceberg and the future of Iceberg, and there was a presentation from Apache, one of the Apache members, about Polaris catalog, and Polaris catalog is basically the future of catalogs. So you can think about that as a federated catalog where independently on the catalog you chose initially to build your Iceberg warehouse, you can basically build the Polaris catalog on top of it, and that will create a federated catalog that will allow you to avoid all the migrations. So in this case, we will have both Frankie and Chris being super happy. And go and check Polaris. I left some details there because it's very promising. It's probably not ready for production yet, but we tested it, 1 week ago with some coding, and it actually looks very promising. Okay, so just to finish, what are the next focus areas? I was telling you about version 1 versus version 2. Currently, we tried to switch to upgrade version 1 tables to version 2. Even if we have version 2 tables now, we are not able to perform upgrades in place. So every time we run an update, the entire row is rewritten. That is not very nice behavior. So the next step will be to investigate why version 2 table do not allow us to actually perform updating plates. Also, currently, given what I was showing you, we are not able to recover data as fast because we cannot like perform simple SQL, there will be the need of having a Spark application querying the data and reinserting them back to a native table in case of data, permanent data loss. And also, if you guys have some experience with, with Spark and EMR clusters in general, there's quite a lot of expertise you need to get like on the ground. It's difficult to, get it right immediately. Like managing resources on a cluster is challenging, and it requires some good monitoring tools, particularly to parse and read logs. So these are some areas we would like to work on in the next future. And this concludes my presentation. Questions?
I think we'll have time for a couple of questions. Anyone has any?
Great. Thanks very much. It was a really interesting talk. I'll stick to one question. You had a custom script for poking the EMR cluster to check the health. Why did you go with like a custom script rather than standard tooling? Is it because of cost, complexity? Nothing out there is good enough. Why did you go custom?
So what you're referring to is probably the sensor, right?
Yeah, task 5.
So the sensor is actually out-of-the-box tool that comes from, with Airflow. So Airflow, when you import the EMR, API, so all the methods that support EMR comes also with sensors. So this is not like a script we built. It's like out-of-the-box Airflow offered method. So you can actually very simply import EMR methods and EMR class in Airflow and have different, options available to build sensors. So actually that took probably 10 seconds. It's very easy. No scripts at all.
Sounds like a better idea. Thanks.
One more, and then we'll move on.
Thanks. I thought that was really, really interesting. So thanks for a great talk. You touched on it a bit about sometimes, your clusters fail, and, tricky to get logs out of EMR. Like, how much have you worked on putting in like custom code into Airflow to get some of that metadata to make like the debugging experience a bit easier?
Excellent question. So this is actually the point, because if we go back to the conversation we were having about the platform engineering team, you have two options. Either you wait for them to actually jump on it and create a better solution to make your logs parsing faster and more user-friendly, or you get to the creative phase we were discussing at the beginning. So I explored a couple of options, and it's actually doable. You can actually, simply parse, read the folder where logs are stored and display them in Airflow. And that will be the easiest solution. It is also very easy to implement. I didn't get there in terms of priority yet, but that is, is very, very doable, in fact, and will spare machine learning from like having to deal with another small project.
Thank you, Antonello.
Thank you.